Alright, and here we go. We now have this thing installed. It is all squared up. You'll notice that I've peeled away the edges. You'll want to do that before you put this in there, because the hope is that you only ever have to put this thing in one time, once, okay? So make sure you peel back the edges. You can maybe see, I don't know, let's see if I can get a shot in there. You can kind of see where I peeled it back there. It's so that way when you go to peel off the rest of this stuff here, it'll you know, come away. Obviously you don't want to tighten down the screws on top of the plastic, otherwise you won't be able to peel the plastic away. So as we flip this thing over, we'll now see that it is nicely installed within. So the hope is that we will never have to take this thing back out again, and Bob's your uncle. Alright, so let's keep on moving on. Next thing we're going to start doing is stuffing these guys. One of the things we need to do is put some diodes on one of these tube sockets here. So I'm going to get set up here and get that done, and then I'll kind of show you how I did that. And I'll give you a little bit more of an explanation as to why that is done that way. But for now, you can just kind of see everything is installed in the box. I had to take out the... see if I can do it from the front. So I had to take out the fuse holder, not the fuse holder, excuse me, the jewel, because it was sticking in where I needed to bolt that guy in. Obviously I was just putting this in for show anyway, but so there you have it. That is, I can't tell you what percentage at this moment in time, but we're getting closer, that's for sure. So, alright, stay tuned. We're going to get some more done. Alright, so now we're ready to wire up the rectifier. You're probably wondering why the hell I'm using some diodes in this amplifier build. There's a reason for that. There's nothing special about these. These are the regular old 1N4 or IN4007s or whatever. Nothing particular for these, or 1N, whatever, you know what I mean. But nothing special about these. They're just, I think they're rated for, oh, I don't know, 1,000 volts, something like that, and something like, enough amps that I ain't got to worry about. But the objective behind the way we're wiring it is that we go into the diode first and then into the rectifier. So that's why I say these things aren't actually doing anything specifically for the circuit other than protecting the rectifier tube. So let's say, for instance, the rectifier tube decides to fail for whatever reason. These are in line and kind of will take over to a degree. Obviously, they're, you know, it's not going to just move the tube out of the way and then work. But what it'll allow it to do is make it so that the transformer is protected in case one of the tube sides short. So if a tube, you know, one of the rectifiers inside the tube shorts, this would be in line next in order to take up any of the, you know, workload that needs to be done. Same with the other side, because we're putting two, one for each half of the rectifier. So the objective is just more or less to protect the rectifier from flyback voltage, so it'll keep things kind of in line there. And then the other thing is to just kind of, you know, have a secondary backup, if you will, if the rectifier tube happens to fail. Now, why does that not actually do anything in the circuit? Well, because from the power supply, it goes to the rectifier first and then into the rectifier tube. So that's why the tube is still doing all of the work. Otherwise, these things are just sitting there like normal, doing what they normally do. It, you know, allows the voltage coming into the rectifier tube just like normal, and the rectifier tube does the rest of the job. Whereas if the rectifier tube shorts, it just shunts this thing, and this thing just does the job of the rectifier tube. So that's how it kind of works in a way. So all the sag that the tube would have is still there, the rectifier tube that is, and all of the other fun stuff that makes a, you know, a rectified amplifier, well, a tube rectified amplifier do its thing. There are very clever circuits out there that use solid state stuff that have sag and whatnot, but I like tube rectifiers, not just for the nostalgia. They're neat. The soft start stuff about them, or the soft start nature of them, is great. Yes, you can build a soft start solid state system, but you can't do it nearly as simply as you can with a rectifier tube. So which one is better? I don't know. Rectifier tubes are kind of one of those things where today it's probably the most common tube to fail in an amplifier. Maybe not, but I would say, you know, it's rectifier tube first and then power tube second, probably in order of failing, and then obviously, you know, your preamp tubes, your 12AX7s, etc., are going to be third in line for things that will fail. So this is just something to try to help, you know, keep your amp running if that tube sort of fails. Sort of. It's sort of. In certain conditions it may keep it running, but that's not the point of it really. These are more to help protect the power transformer and a little bit of the tube, and in certain failure modes these will just allow the amp to keep working. That's really about it. So to do that, we're going to connect the cathode to pins 1 to, and then from there we're going to go to pin 8, and then we're going to connect the cathode to pin 7 and go to pin 2. And then when we wire it, we'll wire it up so that connections come in, I believe, on 2 and 7. Yeah, I believe it's pins 2 and 7 is where we'll actually wire them in. I can't remember off the top of my head, but my apologies. No. Yeah, pins 2 and 7 is where we'll wire in, and what that'll do is actually send it into the tube where it needs to go. So let's do that real quick. I'm going to show you kind of the whole kit and caboodle. So I have here a set that I purchased to do this. We'll break those apart off of their little bands, get that out of the way. Probably don't have to do what I'm about to do, but you can kind of see how the lead is bent maybe a little bit. I don't like bent leads. I think they're unsightly, so we're going to use this little trick here that I probably showed you. We're going to rub some wood together. So you just set the diode in there, or your resistor, and you just rub it back and forth a little bit, and it makes that lead fairly straight. It won't get rid of swoops, but any kind of kinks it will help get rid of. It's a little more effective if you use a metal pair of these, obviously, because it's, you know, gonna squish the fuck out of this thing. But now you can see comparatively, maybe not, I don't know, this one's straighter than that one. That's all there really is to it. So that's the reason I do it. And you can see it only takes a couple seconds to really kind of get your wires nice and straight. So there we go, just like that. We've got two very straight leads, and off to the races we go. So I'll get this guy out of the way, and then get this guy ready here. So you don't have to put, I mean, these guys are a little more forgiving, at least in terms of, you know, putting the pookie on them, I guess you will, but I put them on there just in case anyway. It's a little bit cooler out in the shop today, so we got pins 1 we're going to, and 8. So we're going to put that on pins 1 and 8 there. Just a little bit. And 2 and 7. So there's the other side there. Boy, if I did this right, I'll be so nice. I'm tired, everybody. It's been a freaking hell of a couple weeks. I've been working my butt off. I'm trying to start this new series. Some of you may have caught my original video that came out. I released it. I was very unhappy with it. It was some shoddy ass work. It looked disgusting. I messed up on a couple of my explanations. As you probably noticed, I'm not very good with words. I say and other shit a lot. I don't know what, see, I just said it now. I don't know why that is. I guess maybe I think faster than I can say it. I don't know. Alright, so there's that. I said it again. Let's see if I can get it without bonking anything here. Nope, I cannot. Alright, so I'm going to load this thing up. It's going to take a few minutes. We'll come back in a second. Alright, so got all my tools ready now. Should have done that before, but here we are anyway. So obviously you cannot fit this in there like this, so you got to make it long on one side and short on the other sort of deal. So kind of a way to cheat around that is I usually will find where I want it to go in at. So we need it to go in here, right? And then we're going to cut it a little bit shorter than that, right? So get that thing all the way in. Oop, wrong one. And then we're going to cut it just a wee bit short of that. All right, so that's what you're going to be left with. Then what you can do is you take this guy, and there you go. Now it's centered in there. All right, and we only want to tack it on the bottom. We don't want to go crazy with this because we still got to put some wires on one of these sides. Okay, so do the same thing for the other one, except for we want to make sure it goes the right direction. So we're starting with the cathode over here on pin 1. The cathode is the side with the white line. Okay, I don't know if you can see that or not, but cathode goes to the white line. And then, so we're going to go this way on the other one here. I'm going to keep the long side on the same side for no other reason than why the fuck not. You can do it however the fuck you want when you get it. So just a little bit shorter. Boop. So there you go. And then you stuff it back through. So that's really all you have to do. Some people will bend the leads. I don't think you have to bend the leads. They talk about this whole mechanical connection thing. It's a crock of shit because of the freaking, if the solder fails, then there is absolutely nothing a mechanical connection is going to do to keep your amp running correctly. Because if it is not soldered in place, which is a solid connection in theory, then how would a mechanical connection be any better? If it's not, you know, molded as what should be one, right? So I don't like bending leads around things. To me, it's a little, it's not a needed thing, really. In some instances, obviously it makes sense. Obviously there's many instances, where it makes sense to do that. But in the case of something like this, you don't really need to go nuts like that, like folding leads around. Certainly not a 360 wrap. If you're going to do it, put a bend on each side, like a 90, just so that way it hooks and won't move back and forth. That is totally cool. But you don't need to go wrapping this thing around 5 fucking times. Don't do that. It looks ugly. And if you ever need to change one of those parts, holy hell, you've just made a job for yourself. So don't do that. Others might argue and say, yes, you got to have a mechanical connection that's solid. I'm not relying on a mechanical connection to try to make my day, so that's really all there is to it. So I'm going to cool this thing down a little bit. I had it up at 750, so I'm going to bring it back down to about 730. This thing seems to run a little bit cooler than I had hoped. So that Yeehaw that I was talking about, that soldering station, nice station. I like it. It's, you know, for 60 bucks, I don't think you can beat it. Obviously it's molded or modeled after a, what would you call it? A Hacko or something like that, I think is what the system is. It's great. It's a great little system for what it is. So I like it, but all right. So, but this one appears to run just a wee bit on the cool side, which, you know, no big deal really. So what I try to do is get them centered. I want them to be center of my space. And then we're going to just give it a light little tack down there on the bottom. And if you would hold still, you little shit, and quit making me look like a jackass here. Alright, so now we got that side in. Let's go ahead and get this side in. And if you wouldn't mind melting, there you go. And you don't need much. We're just trying to get this thing, really we're just trying to get this thing tacked in there. That's literally all we're really trying to do. So you don't have to go crazy. You can probably see now why I'm saying it is best to get this done. I still didn't even get it 100% right, but it's best to get this done now than to wait while it's inside of the amp, because if you can imagine trying to get those things down in there like that, it'd be not fucking fun. So they're in there, they're not, I'm gonna do a better job. I'm gonna do a better job. That's bullshit. I'm gonna get better. So anyway, these are in there now. I would just cut them. I would probably at this point just give them a little bend on either side. I'll cut them a little bit shorter and then bend it over. And then, because these are tacked in, so when we put the wires in, you can see that the holes are still opened up. So we'll be able to, maybe you can see the holes are still opened up. But in any case, we'll be able to put the wires in still and then do the job that we need to do. So there's that. Alright, so I now have the first one installed. You can kind of see that there. So as we look at it from the top here, if I can set it down gracefully. And you can see there, it's all in. We got the plastic peeled away there so it won't interfere. I got it pretty well centered there. So what I use is these panhead style, if I can get it in the middle of the shot there, these panhead style 5/16 for this application. I use about 3 different size screws on this job, but you can get these off of eBay or Amazon. Buttonhead 632 5/16. Here comes the wife. Okay, dude. Mwah. So these are 5/16. Another size you may need is like I think 3/8 is the next size up or something like that. You can use 1/2 inch, whatever size you want. The way I try to do it is to get it so that if I can get this out of the way, excuse me. So if you look down in there, let's see if you can get that shot. I don't know if you can get that shot. Maybe you can, maybe you can't. But if you look down in there, you'll see that the threads are just sticking out over the top of the the threads are just sticking out over the top of the lock nut. I like using a lock nut. Obviously, I also use washers. So these are all stainless steel parts, and those I think are what makes a more quality amp. I know that these things will not rust. They are extremely difficult to break, so I know that they're not gonna, fail on me, if you will. Obviously with lock nuts, it's something most companies don't use. I like the Nylocks. I think they work great. There's nothing wrong with them. 632 is the size I use. Obviously, if you use like an M4 or M5 or whatever, if you want to go with the metric, that's great. I try to go with American size stuff, which is interesting though, because these, even though they're American, they use a 2 mil freaking Allen key, but whatever. So you're gonna watch me this part is extremely awkward. You don't have to put this in first. I like putting it in because it's the one part that I know has to fit right. So when I put it in once to test the fit and make sure it's all right, I don't want to take it back out, because every time you take it out and put it back in, it's just one more thing that's gonna get messed up, one more scratch you're gonna put on it. Here in a minute you'll probably actually see me put some tape over this to protect this from the future of this install. So I try to put things in as few a number of times as I can. I do take some things out that are in the way. Obviously trying to get this in there with the fuse holder there just makes it a little more difficult. I took this out just because it was, if I needed to lay it down like this, obviously those aren't going to be a bother. But these are all going to end up coming back out, but I try to remove them as few a number of times as possible. The objective is, of course, to limit the number of times that things get touched, especially on the inside of the chassis, because every time you put your finger in there, it's going to leave a mark. I've got a few marks in this one already. Some of my other ones, obviously, they all have marks, don't get me wrong, but obviously this is built by hand, so there's going to be fingerprints on it. It's not like some of those other... It's not made by a machine where no fingers ever touch it. So anyway, let's... I'm going to go ahead and fast forward. It's very, very awkward to do this. I usually have to stand this thing up like this, and you can't see anything. So all I can tell you is that obviously these guys go in a certain way. You need to know which way that is. So generally you pick the direction. I'm pretty sure that these ones go in there like this. So I've got 2 that go in there like this. They go in from the bottom, like this one over here, just so you know. And then I've got 2 of them that go like, I believe they go this direction, if I'm not mistaken. But in either case, I prefer bottom mount. Now there's a reason for going with bottom mount as opposed to top mount. Another thing is I don't like using like the tube springs and stuff like that. I think they rattle. I don't like them. If you have a good connector like these are nice built-ins, you should not need them. If you are rattling your amp around to the degree where it is knocking the tubes out, 2 things. One, it's probably you need a new tube socket that holds the freaking tubes in there correctly anyway. Number 2, well, all I can say is that you probably need to put it in a better case, or put it in a spot in your truck or however you're transporting that thing, in a place where it's less susceptible to getting knocked the fuck around. Obviously, if the thing is sitting upright, these things should never rattle out. In the 10 or 15 years, no, excuse me, 20 years that I have been, playing the stages and stuff like that, I've never had a tube freaking fall out. And I usually, the first thing I do when I get my amplifier is tear all those freaking tube shields and tube clips and stuff out, because I don't like them. Now, it is a different story when you're using a combo amp and the tubes are literally hanging upside down. Obviously, in a case like that, I think it would be wise to have... I am totally off the rails right now, by the way. Why are we talking about this? I don't know. But hey, here we are giving my thoughts and opinions. Anyway, obviously with a combo amp where the tube is, hanging down, that might be an issue. Yes, I would use springs and stuff like that in that instance. But in an amp that is supposed to be sitting in this orientation here where gravity's trying to keep that tube inside, should never be a problem. And with my amps, it will not be. At least until this thing wears out. And when this thing wears out, by all means, send it back to me, and I'll fix it. I don't think I'm going to be alive before you need to send it back for one of these going bad. So that's the hope anyway. Anyway, I'm just going to do this, and it'll come back, and all these things will just be installed. Alright, so we have gotten all of the tube sockets placed in this thing. I went ahead and cleaned up a couple things here, taped these off to try to keep them out of the way. So you can see that they are all, see if we can get a closer shot of that. I don't know if you can or say, whatever, you know that they're in there. So obviously with the washers, I use, it's a 632 stainless washer, nothing special there. We've already kind of gone over this. 632 5/16. That's the size I find works good for this here. I don't use a washer on the top side. I don't like the look of it, and I don't see a need for it. So these are just kind of raw there, but I like that look, so that's great. I do use a washer on the bottom because the plate that holds this thing in is pretty thin, and I don't want to, you know what I mean? Like, so I use a washer underneath there. I don't know if you can see it or whatnot, but washer goes underneath the nut, and of course the 9-lock nut. This part is probably the most tedious, biggest pain in the ass portion of the whole thing. There's not a lot of room on the edges, and there's not a lot of room in between them, obviously. And because of the way the sockets are, I don't have another one readily available. Yeah, I do actually. Hold on. I got one here with a tube shield, but as you can tell, this one goes on the top, so it's not as big a deal, but when you look down, you can see there's no room to get a socket. There's no room to get a socket beside this thing unless you have a thin wall socket. I haven't gotten one of those yet. So what you normally end up having to use is some sort of, box end or some other thing. And then of course you're working on two sides of the amp, and you got to tighten it with one, and there's just not a lot of room. It's the most tedious, biggest pain in the ass thing to do. But it can be done. Take your time, just do it right. Try to make it neat. These are all well centered in their hole. Not that they're not easy to center, because the hole is almost perfect in size. I didn't have to even go back and touch up any of these holes even to make them fit in, which is nice. This thing here came out perfectly square, and obviously it sits in its place like it's supposed to. So we are getting down to the part literally where it's time to start figuring out where this and this are going to go. So the output transformer needs to have a home. You can see here I didn't clean the leads yet on this. I got some work to do yet still, so we're getting there little by little. This one's all cleaned up, ready to go, and some more of this. What's nice about this paint is it doesn't really stick very well to these wires, so the more you move it around, if you missed a spot like that one there, it'll come off for you. Yeah. So in either case, we're getting down to the point where we need to wire this thing up to some AC and connect our headphones to this guy here, and we will, go from there. So how do you wire this thing to AC? Well, I believe it's the white and black here and the black. So white and black. These ones are backwards. It's actually written on the box, which I put away somewhere, but if I recall correctly, black is line, and then white and black is neutral, and then this red and black we're not going to use that. That's going to go away. So you'll literally attach these two ends right here to an AC source, like your outlet, whatever. You can do it raw, so you can alligator clip it if you want. It's a little dangerous, but then all of these other connections over here are going to get taped off individually. Individually, they will get taped off, so they can't touch each other and they can't short out on anything. And then on this guy here, this is the output transformer. These guys here, it doesn't matter what you do with these. It doesn't matter. There's actually no physical power going through this at all. So this one here is not the danger side, really. But what you do is you connect this black wire here, if I could get it to separate. So there's a primary side, which is this side here. So the red one here is your center tap, and then these blue and the brown are your primaries, right? So those will go to the plates of your tubes, and then the red one here will go to your center tap B+ location. I think it's well, I don't have the schematic, but it goes to your first node. Anyway, and then you've got your yellow, orange, and green wires, and those are your secondaries. You got your 4, 8, and 16 ohm taps, right? So the ground is what actually makes either one of these work. You can't use them in tandem, but you can use one or the other. So pick one. It really doesn't matter which one, but you take the black. Oh my God, if it would separate. You take the black and let's say the orange, and you put the black on the ground of what would be the ground of your headphones, and then the orange to the tip or ring, or tip and ring if you'd like, to your headphones. And that is what will allow you to listen to the buzz that comes from this guy. So how that works is when this is plugged in, you set it down like this, right? And then you have your headphones attached to these two wires here or something like that. These ones don't matter. There's no electricity that's going to flow through this. And then you just move this thing around on the amplifier while it's, while your headphones are connected, and listen for the, you'll hear the buzz. And then you can turn it, you can rotate it 180 degrees, you can put it over here, you can put it there, you can put it here. Wherever it ends up being the quietest or the lowest noise is where you want to place that thing. I suspect it's going to end up right about there. That's my guess. Should end up right in there somewhere. It's not quite in line with this. Usually it's not quite in line with, I don't know if you can even see it, but this guy here, this is the, oops, sorry, did it again. High cut. This is the high cut knob there, but it usually ends up just inside of there somewhere. But it depends. Sometimes the orientation of your power transformer can affect things, but this one's a fixed thing. We can't really move that too much. This one's going to stay where it's at, and then you find the best spot for this one. It will never be completely silent. You're just looking for the most silent. Objectively, if you get it just right, it should be dead silent, but you can't always win, so you take the best that you can get. Most of my amps are dead fucking silent. Most of them. Sometimes, when you got gangbangers or you got a lot of stages, obviously you can't win. Single coil pickups, you can't win with single coils all the time, but most of the time, when you hear the recording of this thing, you'll realize really quick what I mean. Like, this thing is about as quiet as one can ask for an amp to be. So the next thing I'm going to do is I'm going to put the standoffs on here. I know where they're supposed to go on here, so I'm going to go ahead and put those standoffs on here. And then as we move forward, you're actually going to see me, because now we're at the point where we need to figure out where that transformer is going to go. So here we go. Let's move on. All right. So we've done a little bit of work off camera. Don't worry. I'm going to explain it all. You're going to get an earful right now. So a little bit has gone on. It's been a couple days now, but I finally got my True One connector in the mail. Super duper happy about that. I decided, as I mentioned earlier, that I'm going to go with the Neutrik Power One or True One connector for this amplifier build for a couple different reasons. I think IECs are inferior, at least to this connection. I wanted something that's easier to install. The unfortunate thing with a blank chassis, to put an IEC in, you have to put a square hole or a rectangular hole. Some even put the little trapezoidal shaped hole in there. It's a pain in the ass to do, The bit to do it, the tool to actually do it, costs like 300 freaking bucks, and it's an inferior freaking part. It's great for your computer that never moves. It's great for some things that don't move often. Your guitar amp is maybe, if you're a bedroom player, it's never going to move, but if you're on a stage or you do a lot of touring and stuff like that, you want a freaking connection that is just superior. This is that connection. You cannot fuck this shit up. So what's nice is that the newer version, this is the True One Top or whatever the hell they call it, but they finally make it look like a normal freaking connector. It doesn't look like the old power cons that were, blue and yellow. God, talk about ugly. Can't say you didn't see it though. But so there's that. A couple other things. This is rated for hot and hot switching or hot swapping, so you can actually make and break this connection while your load is actually on, which no big deal, whatever. They have done some things on this one. They've added another tab on here to make it damn near impossible to put this thing in and clock it wrong. Don't ask me how. I've been doing sound for 20 plus years. There are people that are dumb enough and aggressive enough to get these things, not this particular one, but to get the original power cons and even the true ones, the old ones with the yellow tab on them, to go in and clock wrong. I don't know how the hell you do it, but there are people dumb enough to pull that off. So this one, very much more difficult to do. Another nice thing about this one is it's IP rated, so it's outdoor rated. So you can spill your beer over the top of your amplifier and the Angry Pixies ain't gonna try to get out and bite you through at least the power switch, or power connector, excuse me. So this one here just requires a circular hole. You're not gonna see me drill it because I'm sure you don't need to be watching me fuck around with the unibits, but whatever, I digress. Here's where I'm gonna ask for some help on this matter. Maybe somebody will watch this that knows a little bit more about it than I do. I've done a bit of research on it. There are two schools of thought though. It's about 50-50 split on how people will wire their amps up for their power source. So there are fuse first individuals, and there are switch first individuals. I am a fuse first individual. I feel that this is the safest thing to put first in line with your wall power, because then that means that if anything happens between here and the rest of the amplifier, the fuse blows up and everybody's happy. Everybody gets to go home safe and sound. That's my thought process is. To the best of my knowledge, most all appliances, at least in the USA that I know of, the power comes in and it goes directly to a fuse, and then from there it goes to the switch and then the rest of the appliance. I could be wrong, but to the best of my knowledge, that's the case. And then logically speaking, to me, it just makes sense to have the fuse first, because if anything happens anywhere else in the amp, between there and your source of power, the fuse will be there to help try to keep some of the bite off of you, if you will. Now, the switch first individuals kind of have, and it's a good argument. I'm not saying it's bad. I'm not saying it's wrong, but their argument is that if the power comes in from the wall, goes straight to the switch, that when the switch is off, that there's nothing else that can go wrong elsewhere in the amp. You can fiddle a fart around, you can change the fuse, and yada yada yada, and should be safe. That is right. It is true that if you turn the amp off and you know that it's off and you go to change the fuse on this guy, that you won't get shocked because there's no power coming into it. And I'll explain why that's a good argument. So in here, if you go fuse first, the power comes in to the back side here on this back tab, and it goes through the fuse and then back out via this top tab. Right here is that fuse. Now you'll notice that when I took the fuse out, the little innard part came with it, or when I took the cap off, the innards came with it. Inside of here, I don't know if you can see it, but down at the very, very bottom there, you can kind of see that shiny little bit down there. That part does have Angry Pixies sitting on it, waiting to jump up and bite you. But this outer ring here, the one that's connected there, you can't, it's safe. It's not touching anything. So even if hot voltage is there, you can't shock yourself unless you're dumb enough. People are dumb, don't get me wrong. If you put something in there like that, without the cap on it and touch that, yeah, you're gonna get a jolt. You're gonna feel it. It's gonna hurt. But if you're a smart individual and not a dumb motherfucker, you'll know that you shouldn't be fucking around with any kibble and bit inside of an amplifier or any other appliance for that matter without disconnecting the power first. That's why I feel it's kind of moot to go with the switch first argument. But in either case, that is the one thing that their argument does fit, is that at least in that instance where you go switch first, whoop, caught it. This guy at least won't be hot, which means if you do go fiddling around in there, you won't get hurt. But the problem is that what happens if that switch shorts out or finds a way to connect to something that it should not be connected to? Well, if the fuse happens to be after it and it finds a way to get to something that's not, you know, with the fuse in it, that thing's gonna have a freaking angry pixie dance or war or whatever the hell you want to call it until shit turns into a molten blob. Well, if this is in first and that happens, this will just pop and, you know, everybody's happy. You probably won't even know something happened, to be honest. So here's the other common sense part about dealing with this first. If you do happen to blow the fuse, that means something went wrong to blow the fuse, which means you probably shouldn't be trying to find a way to make this amp come on right away anyway. You should be trying to investigate, if you will, why this amp popped this fuse, which means you should be disconnecting it from any kind of power source to then verify why this guy went up in smoke, why that little thing in there said, nope, we can't do this anymore. So that is it. But I am open to suggestion. I am open to empirical evidence. Don't tell me I'm just a dumbass and I should shut the fuck up and quit doing this while I'm still ahead. Show me why, tell me why, you know, and you know, let me know in the comments. I'd like to hear a little bit more about it. Are you a fuse first guy or are you a switch first guy? I'm a fuse first guy. So, other developments. You'll notice that some of these wires are twisted up. Obviously, I don't think you need to see me twisting up wires. It's not hard. I found the two that I need to be connected together or twisted together and just twist them together and try to get the wire to form more or less where I need it to go. This particular transformer, you saw me do the opening of the box. This one has several taps or secondaries on it. I guess we can start from the input side and we'll work our way out. So on the input end, we have the black wire, which is just the line. Universally in America, the black is hot or line. And then we have the black with white banding on it. That, you know, white being universal in America, at least anyway, for neutral. So these two are the ones where the angry pixies bounce back and forth with and make shit work inside the amp. We got a couple of center taps here. So the red with yellow band and the green with yellow band are the center taps for the HT and the heater, respectively. This one has another tap on it, though. It's actually got two other taps. It has a separate heater winding for tubes that require, you know, their own discrete heater winding. There are some tubes that require a discrete heater source. This one here has a 6.3 volt, which is what we're using, and a 5 volt. The 5 volt tap is down in here with this blue tape. They're just tucked out of the way. The other thing that's kind of tucked in there in that blue tape is the 240 volt input. The 240 volt is obviously for the European countries where, you know, they get 240. So those ones are tied off because they're just not needed. So some rectifiers need 5 volt heater taps, which is what that 5 volt tap is for. 5AR4, 5U4, GZ34, whatever. Those require 5 volts. That's part of the name and the, you know, the nomenclature on there. There are other tubes, as I had mentioned just a moment ago, that actually require their own discrete source of heater voltage. So that's that. This is the HT winding, as I mentioned. This is where the 290 volts comes in. So this is a 290 0 290. When you see that, a 290 0 290, the 0 is the center tap. Okay, so the HT comes into the rectifier, and from the rectifier it goes out to the rest of the amplifier, and it should produce, in this case here, about 340 to 350 volts, thereabouts, depending on the wall voltage that you have. So that's all the fun stuff. I am going to do a little bit of work. You're not going to see it, but when I come back, you know, we'll see what's going on. To explain why I have gone through the trouble of all this so far is that in order to do the headphone trick, we actually need to have some of this transformer doing at least something, which means we need to have the center taps at least grounded. And then just to make it a little bit safer, what we will do is put the heater taps to the respective places that they need to go. We'll put the HT onto the rectifier there. Of course, the heaters will go to the heaters, yada, yada, yada. All that stuff will get tied to where it needs to go. And as long as I don't put tubes in there, this amp will be safe. You know, the connections will go where they need to go, but they're not doing anything. And then with these guys put to ground, the secondaries will actually function, which means that this transformer will actually have some amount of loading on it, which will help make it a little bit noisier, which will make it easier for us to place our output transformer. So that is why we are going through this trouble right now. It is worth it for everybody, or for me, to, you know, to make it safe to do this job with, to connect everything. So nothing is sitting out and loose and where it shouldn't be, where I can, you know, accidentally get something to touch that shouldn't be touching. So we'll see you here in a few more moments. All right, so we've made a little bit of progress. I got these things kind of tied down and in place a little bit, just to kind of help things out a little bit, keep them out of the way. I put the switch and a couple things back in because we're ready to actually start wiring them up. So again, I'm going to show you all this as we go along. I'm just not going to show me doing the work at this point, because some of it is just, you don't need to see me strip a wire and, you know, crimp on a fitting. I mean, come on. So, all right. A couple things. First, in the last little segment, you know, the one before this, I talked about switch first versus fuse first as an argument. I did a little more research on it. My understanding of it seems to be correct in that it should be fuse first before switch in order to be code compliant, at least in the Americas. Again, I'm still open to, you know, empirical evidence, and, you know, if somebody can actually cite some more code or something like that, something that refutes that, let me know. I'd love to see it. But as of right now, I'm going to sit on that egg until it hatches. So there's that. So a couple things. I do not have white wire in 18 gauge. I don't use anything with white wire that is in 18 gauge. So I use just two black wires, even though this one is carrying a line and a neutral. So what I do to denote that is at the end of each line, I use a black and a white shrink wrap to denote it properly. However, I do feel it is important to make sure that ground is known to be ground. So I do use green wire for that. This is not the same as this type of wire here, but this is very evidently your ground wire, and I think that is important to do. Some notes on the installation of your ground wire. There are a couple things that you need to keep in mind when you build your amplifier. First and foremost, that you want to keep your power lines as short as practical. So this one is going to go here from my fuse across the way over to the switch. This is my neutral line here, so that'll run next to it. They'll get tied together, and there'll just be a little bit of a hump here, so there'll be enough room for you to be able to disconnect and reconnect it, but it'll be relatively short. Almost as direct a line as I can make it between the receptacle and the switch, and etc., etc. So that way this is as short as practical. That being said, it is wise, actually it's to code, that you make your green wire a little bit longer than it needs to be. And it should be, in theory, as close to the receptacle as you can get it, but not connected to any of the connectors that go to the receptacle. It needs to have its own connection that gets this thing attached to the chassis. I'm going to do it probably down over in here somewhere, I think. Historically, I've done it literally on the back side of the panel right next to it, but I think I'm going to install an HT fuse right here, and I don't feel like putting it right here. I feel that I'll get it a little too close to some of these other things. I want it to be over here or something, so I'm probably going to end up with it over here somewhere, but I'm going to use something that attaches firmly to the chassis and has this on it, excuse me, and this will be a little bit longer than it needs to be. And the reason for that is that if this receptacle should ever get pulled, yanked out of the amp for any reason whatsoever, that your ground wire is the last wire that can possibly have its connection broken from the amplifier. You want your hot and or your neutral line, both technically, especially your line, but you want these to get physically broken from the receptacle first, prior to any possibility of your ground wire getting broken, for obvious reasons. This is what's going to protect you and save you from being the ground path for anything else that, you know, can go wrong. So this needs to be long enough that if the receptacle gets yanked out of the amp, this is the last wire that can possibly get broken. So that's it. That's all there is to that. For me, as I mentioned, I don't have white, so I'm going to use shrink wrap to denote that. And then, of course, I got black shrink wrap too. So this one here will just, you know, put our thing on there. I do have white wire in 22 gauge. I'm going to use that for the switch, excuse me, the pilot light. Now, the reason I'm using white for the pilot light is because this is able to be removed and taken out, because I'm going to use a connector like this. Let's see if I can get that up there so you can see it. It's got a way to connect two to it. So you connect one wire in, it goes on, and then I can connect another wire from it to something else. So this will have a spade on the end of it. If you could freaking get in the camera view, there you go. So these wires here will have a spade on one end, and then the other end will connect directly to the pilot light. The reason I want the pilot light to be permanently attached on the one end, it's actually going to be soldered on this end here, is because this does have a polarity. I want to make sure that the inside pin, the one at the very bottom, the one that you can't get to unless you're trying to be stupid, is always going to be the line. And then I want the white, or the neutral, if you will, to always be the neutral. So this one I do wire with the two colors, so that way there's no mistaking it, getting it wrong. Over here with the shrink wrap, it doesn't really matter what side is which on the switch. The switch doesn't give a shit which side is hot or neutral. But as long as you put white to white and black to black, you're good to go. So there's no other grounds other than this guy in the amp, so that we don't have to worry about. I am not going to show you me actually stripping the wires and putting all these connectors on. I'm just going to kind of build it, and you're going to see. So the next clip that you'll see, a lot of these things will be shortened up quite a bit, and they will be kind of placed in their spots, and we'll go back and overview everything and make sure you're up to speed on what is going on with this amplifier build. So thank you so much, and stick with me. We got more to come. Hey, more good news too. Check it out. So remember I was talking about getting the 15 amp switch versus the 6 amp version. The one that I initially had in there, which is this guy here, is the 6 amp one. And I was telling you that it had to, for me, it's better to get the 15 amp because it's got the more ka-thunk thing going for it. So this is the 6 amp one I'm switching here, right? This one's the 15 amp. Very firm. Like, that is an affirmative hell yeah brother right there. So I like the 15 amp. I just didn't have any in stock. That came in the mail literally moments after I started getting ready to do some soldering and whatnot. So this is the 15 amp. Something else I got. I get to do another box opening here, sort of. I got these beauty rings, you know what I mean. So I like this style here. I like them because they're a little bit thicker. Obviously, they're nickel plated, so they go on the outside of the switch, and they look really, really nice. So we're going to use this on the outside of the amp, and we'll get that set up so it's really square like that in there. And yada yada yada, Bob's your uncle. So super excited about that. So we'll get this guy put in. If I can get you to line up the other way, however. There we go. So we'll put you right there. And then this guy will go on the outside. Oh yeah, we're gonna have to take a little more out. Mo better. So let me adjust this a little bit here. I'm just excited. I got to put it in right now. It's the little things in life, right? I don't know. Maybe I'm just goofy like that. Little things like that just get me all excited and happy. If you don't mind, please. Oh my goodness, it's gonna be like that right now. It's gonna be like that. It's like, oh, you want to play? Hold on, let's play. There it is. Nailed it. Nailed it. Oh yeah, much better now. We're much closer now. Oh, that's gonna look so good. I love that. All right. So just a little update. As much as the 6 amp is definitely more than enough switch for this amplifier. We're not pulling 6 amps on anything in here, so that's not the problem. But this switch just doesn't feel. It doesn't have the feel that I like, and I'm all about the feel. So this switch here, you hear that right away. It's like back, like you know that amp is on. It's kapow. So anyway. Thank you. I just had to get that out. Alright, just another little update. So I start with one side first. So I actually got one of these wrong. Because you know, you didn't fuck it up unless you fucked it up. So one of these actually needs to be a white one. So I'm gonna have to redo that. But see, that's what happens. I was mentioning earlier that you know I'm not designed for doing these types of things. So I'm sitting here trying to. Alright, here is a quick update about what's been going on. So as you can see, we've gotten a bunch of things wired, not everything yet. I'm still holding off on these guys here, the center taps, until I know where the turret board is going to land. The reason I want to wait until I know where the turret board is going to land is because I'd like for it, because this is the ground that's going to come off and go to this position here, where these end up at. So I'd like for that to be in line with this part of the turret board. Well, since I don't know where the turret board's going to go yet, that means I really can't just go and inadvertently put the ground point for that portion of the chassis. So I will probably ground these off to something else in the meantime. I haven't yet decided exactly where I want to put the chassis ground yet, or the safety ground. Part of me wants to put it down here. Another part of me wants to put it on either side of the receptacle. And another part of me wants to put it over here in the corner of the chassis, but I haven't yet decided exactly where that's going to be. But let me show you some of the work that we've gotten done here. See if you can get it in there, and you can just kind of see what's been going on. Obviously, I've got the line and the neutral, you know, noted by black and white, like I mentioned, and everything's kind of laid out there. Let me tell you, this is a very tedious task, and it still didn't turn out as good as I'd hoped. Trying to get these winds to look perfect with as stiff as this wire is very difficult to do. I may change to this style of wire later on. Since there is no soldering going on with any of these, I don't really need to worry about, you know, the non-melty Teflon coated wire shit, but because this is just normal hookup wire here, so nothing special about that. But the normal hookup wire is definitely much easier to deal with. That pre-tinned, excuse me, Teflon coated stuff, you know, it's nice because it bends and it stays put like a solid core wire, but definitely does not flow and move around, and it's not as malleable as, of course, just standard wire. But that makes doing this job very much difficult, very much more difficult. But God, when you get it right where you want it, it stays put, it looks great. So this, I'm happy with it. This is one of the better jobs I've done. Everything here is kind of in a line. We've still got some more connections down there to make. I haven't gotten to the HT or the heaters yet, so we got to do that yet still. The 240 volt tap and the 6.3 volt are just tucked right here. And what I have is the wires, you know, they're just terminated, and then I put some heat shrink over the end so it goes over the end and sticks over the, you know, whatever. And then I put another piece of heat shrink over the both of them, and then they can just stick down there and stay out of the way. So that's done. So all we really have got left to do is connect these heater wires and HT wires up over here. And then over here we got to get this heater wire done up. So once we get that, then we can figure out where we're going to ground these off at. And then we can actually get to doing the you know, the headphone trick, if you will, finding out exactly where we're going to place the output transformer. Once we know where the output transformer is going to go, then we can find where we're going to place the turret board. Once we know where we place the turret board, we can put the grounding point for the center taps and the, you know, and the star ground point, if you will. And then, of course, I've got to get this guy done up too. So some decisions to make and just a couple little jobs to do. So there's a quick little update as to what was going on. And, well, we'll see you again here in a few. Alright, another quick update. We haven't done too much. It's been a little bit longer. I want to say that I probably spent about another beer and a half on this. I'm not kidding when I say that probably the most tedious part about building the amplifier is going to be wiring in the power section. Let's make this so you can see it a little bit better here. It's going to be wiring in the power section and getting the heater wires all ran. The reason being is just that you've got a lot of wires that go to a lot of different places, and of course the objective is to try to make them neat and, you know, orderly and just all the above, right? So I've gotten everything kind of where they need to lay. The heater wires here are still not connected, mainly because I still need to run the rest of the heater wires before I solder that in, or I at least need to get this set done. Something I don't. At this point, it wouldn't matter if I ran it or not. They're not shorting out to anything, but for posterity, right? So over here, I did decide to go with the ground on the top of the chassis. It just seemed to be the closest way. I don't know if you can see that or not. It's down in there, but more or less what it does is it attaches there at the top, back behind the rectifier tube. I opted for that for a couple reasons. Reason number one is that if you mount it to the back of the chassis on this side here, there's a panel that has to go there. Well, it can't protrude through the panel because you need metal-to-metal contact on both sides of that screw, because you want that thing to be that has to be a very solid connection. So you have to countersink the screw behind the panel. Well, the trouble I've had with it in some of the other amps that I built, and it's really not trouble, it's never going to come loose, but it's that you got to countersink it, which makes the, you know, the metal a little thin. It's already pretty thin, and then, you know, you can't access it if it ever does happen to come loose, or you do need to get to it. You can't access it. So the only way to access it, of course, would be then to take off the panel, which means you basically have to take everything apart to service that thing, if ever you should have to. I wanted to get away from that, but I don't want to put screws on the side of the chassis. I don't want, you know, so I opted to put it on the top side as kind of a compromise, if you will. From a technical standpoint, it is still closest to the receptacle here, so it is very near the receptacle. It'd be very hard for anything to happen in the 2 inches that goes on between here. And it's done in such a way that if this thing were to yank out, this thing would be the last thing to tear, because I didn't leave a whole lot of room in here. And keep in mind that these are all going to swedge out a little bit further. Maybe not so much. Yeah, this one here is going to sink in, so they're going to swedge out a little bit. There is a remedy to that problem. You'll notice that I coiled this wire up here. The reason that wire is coiled up is if I need to make this thing a little longer, you can undo a couple of the coils and that will make it a little longer so I can adjust it. There's ever so slight of an arc in it, so it's kind of looking like that almost. And the objective behind that is so that way it doesn't have tension on either side, But if you were to pull the receptacle out, it would hopefully, it probably should, I'm sure it will, start yanking off on those connectors, and one of them will let go long before this 2 inches worth of pull here lets go on these. So there's a little bit of design to it. It seems a little wacky, but as you can kind of see, or maybe not, I don't know, I'm going to try to make it so you can, but obviously I'm just trying to make things straight lines, and if anything does cross, I want it to try to cross at a right angle. In terms of the heater wire and the HT, that is not as critical. Things over here are not as critical if they're at, you know, right angles of each other. Obviously the ground, it doesn't care, it's just going to shunt stuff to ground anyway, but the heater wire here is going right next to another heater wire, so all the noise in this amp is right here, or on this side over. So as it goes this way, it'll get quieter and quieter and quieter. So objectively, I've done what I need to do. Now a little trick to do once you kind of get all your wires placed is to take like your heat gun, because you obviously need like a heat gun or something like that to, you know, do all your shrink wrap. I highly suggest you get a heat gun. Go to Harbor Freight, get the heat gun. Don't be using lighters and, you know, or, you know, the little flame torch things. Don't be doing that stuff. Just go and get the $15 heat gun from Harbor Freight or whatever. Once you get all your wires kind of placed where you want them, heat it up just a little bit. You don't need to cook them, but you just want to get the wires warm so they get a little malleable, and then you get one last little chance to kind of put them in their little spots where you want them to be, and as it cools, that's kind of where it'll settle to, which is kind of the neat thing about doing it the way that I've done it. Shouldn't say the way that I've done it, but you know what I mean. When you do it this way, when you have things that you want to like lock into a certain orientation or something like that, maybe it's there already, but heating it up gives you one last little chance to like eke things into that little spot and get it to lock in, because as it cools down, it'll harden. It's trippy. You just got to try it. So do the heat gun thing and yada, yada, yada. I still haven't dealt with these. These are the last thing I need to deal with, but I am at the point now where I need to start finishing the heater wires, which, let's see if I can get it so you can see all that crap. So down in there is where the heater wires come from the transformer. Well, I need to run them across to all these other spots there. I kind of feel like I need to do that first before I call it buttoned up and done. The downside is that it is a little more challenging, of course. It's one more task that you have to do. Like I said, if you really want to just jump ahead to the point where you're just trying to find the location of the transformer, all you got to do is tape those things off so they don't short to anything, and you can, at this point, just ground these guys out, the center taps, ground them out, and you can move forward. But for me, I like doing things so it's clean and that there's no whoopsies involved. So I'm gonna ground these out to something here in a little bit, but I'm gonna finish the heater wiring, and when we come back you'll see that, and then we'll start moving on to the fun bits. All right, I figured I'd give another quick little update as to what's going on. Obviously nothing so far has changed since the last time you saw me, but gosh, man, Red Bull, man, for the win. Just give me the burpees though. My apologies. I've got this camera zoomed in a little bit, so you're gonna see my fucked up hands a little bit more. I'm gonna work them, man. Sorry. Anyway, so I've got red and black here. Those are my colors. Okay. So I'm gonna wire in the heater circuit before I do the big test that we're all waiting for here, the big lead up that I've been running up to. But I decided to go with 18 gauge, mainly because I'm a glutton for punishment, and you know, I like to over engineer shit and make it more complicated than it probably needs to be, because why not, right? So 18 gauge is more than superfluous for this circuit. I'm gonna do it just because. So there we go. So we're gonna go with 18 gauge for the first two tubes, the power tubes, and then we'll switch over to 22 gauge for the rest of them. I'm using two colors, red and black. Now the way I kind of do it, is I kind of get this started. I can already tell you right now that I'm off by a wee little bit. We need to tighten up this corner here just a little bit more, so I'll go ahead and do that now. But I also know that what I just did is probably not going to work because I needed this to come out a little further. But the way it works, I'm going to try to keep things in the shot here, is I get this in there. I get this in there. There we go. And then I kind of get it lined up there, and it lined up pretty good. But the problem is I need to go out and over with the black wire the same way. So I'm going to basically be creating this exact same part twice. And I managed to get it pretty good, but I want to come off the turret lug a little bit, off the lug a little bit, and shoot it in so I get some distance. So this will modify a little bit, and then we'll of course punch it into this other one here. But before I solder that, I'll have to get my 22 gauge in there and wire it up to the other side over there. And you can see why right now I'm not trying to film me doing this crap, because my hands are in the way and you're just going to see me fumbling about trying to get all this wire to fit. So what I know is that this one is pretty dang close where I have it. So I just need to fine tune it a little bit to make it all work together, and then create an exact replica of that with this guy. So if these both are the same, they should both fit, because the sockets are going in the same spot. And Bob will be your uncle. Then I can solder this section up here. Again, you probably can't see it. So I'm going to solder up these guys here, and then we'll move on down the line. Again, just to reiterate, this is the most complicated part of the whole amp build, is trying to make all your runs nice and clean. You want to try to get them all pretty like and stuff, and that's the most difficult thing to do, to try to get your amp to look like a Matchless does, or oh gosh, what's that other company that's known for that stuff? High Watt. If you want to try to make your amp look like a High Watt or a Matchless, you've got to spend a lot of time. Some of it's trial and error, because you're modifying things as you go along, because you're just trying to get everything to be all tidy and neat and straight lines and right angles and this, that, and the other, and it just doesn't always go the way you think. So anyway, just wanted to give you a quick update as to how I at least come to my wiring scheme for the heaters over here. Now, why are we going with different colors though? Maybe we haven't really tackled that much. You want to try to, whatever you wire your first tube up to, you want the rest of them to stay in that order. So if you use two different colors, and if you put it on, that lug, it's going to stay the same all the way through. And the reason you want it to stay the same all the way through is CMR. So common mode rejection exists on at least the power tubes and the phase inverter. They have an in-phase signal and an out-of-phase signal that exists within those tubes. Excuse me. So you want to be able to utilize the CMR, because with one being phase and anti-phase, any common, any noise that gets injected upon them that is common to the two, when they're summed back together at the output transformer or wherever it is that they need to sum together at, that noise will get re-inverted, right? It'll cancel out at that point, because 1 minus 1 equals 0. So that's the objective idea, is to try to make it so that the noise injection potential is the same all the way around. You do not have to twist your wires. I will not be twisting these. At least for this portion of the amplifier will not be. I may twist the rest. Just haven't decided whether or not I will or not. I usually don't between the phase inverter and the other one. You don't have to twist them. It's mostly about just being smart with your layout. And objectively, what you're trying to do is make it so that way your signal doesn't get too close to your heaters. So that's why, generally with heaters, the single best way to do it is to come in over the top and shoot down into the tube, and then come back up, over, and then back down into the tube. Now the object behind that is that all the noise is like this narrow little tube that shoots down onto the axis of the tube. which means all of your signal wires can come in and around, you know, around that noise point there, and it won't get, you know, won't get picked up. Well, the alternative to that is to make it so that way your noise, you know, your tube of noise, if you will, goes down the center, right? And then all of your signals come up, over, and down. There's debates on either way. The single most important one, of course, is your input tube. That one definitely has to be right, which is why I'm doing it the way I'm doing it, because the signal, the noisiest part of the whatever, imagine there's a red wire there too, but so it's going to end there at the 9th one. So all the noise is coming in from here, but the way that this tube socket is working is the grid is down here. So the signal will come in, it'll float around the edge of the chassis and then come up into it, where it will be nowhere near any of the noise. The plate and the cathode are not as affected by the noise off the heaters as the grids are. The grids are the important thing, where you want to keep the noise off. So the phase inverter, again, not as susceptible to noise because of its CMR capabilities. Power tubes, again, not as susceptible because of CMR, same. So this tube here, the way I have it done up right now, will work out pretty well because I can keep the signal away from it, and all the noise will live right up the middle. So it won't radiate too far out and get onto any of the other grids and stuff like that. And I can keep things up and away from everything. So that's the objective there. Anyway, I am not going to have you watch me do this, but we're gonna get all this stuff installed, and when you see this again, obviously this will be done. So thank you much. All right. I know what you're thinking. You're thinking, Luke, you're a cheater. You've got a scope over here. You said you were going to show us how to do the headphone trick. Well, the problem with the headphone trick is that you can't hear the headphones. Only I can. So I had to come up with another way. Normally I would do it with this, with the scope, because it's much, much quieter. But what's kind of cool is actually having something that you can listen to will kind of get you to the more the... I guess the real world, like you can look at this and yeah, sure, the signal goes away and at some point you can't tell a change anymore, but when you actually have something to listen to, it really makes things come to light. Now what you can't see is that I have this thing connected to the amplifier, and that is done via, I'm cheating here, I'm using an input plug, and then I'm just shorting the, or jumpering the,